Assalamu alaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Welcome back, dear students. Today we are going to start 16b, addition of probability. As you know, yesterday we started the lesson probability, and yesterday we discussed about the simple event. Now we are going to discuss about the addition of probabilities. For example, if we have two independent events, so for the two independent events, how can we add the probability of these two independent events? For the addition, for learning the addition or to understand the addition of probability, we need some terms to understand first, like that independent events and dependent events, mutually exclusive events, non-mutually exclusive events, and this kind of things. So let's start with the introduction first, and then at the last slides I'll try to explain the addition of probabilities. This is the first issue, mutually exclusive event. For finding the mutually exclusive events, we should know that events having no outcomes in common is called mutually exclusive. For example, event A. In event A, the numbers 1, 7, 9, 5, 3, and event B 2, 8, 6, no same value in both the events, event A and event B. So this is called mutually exclusive events. For the addition, rule of mutually exclusive events will be probability of A union B. It is called like that. If A and B are mutually exclusive, we will present that. And just keep in your mind A union B. This is not the sets rule. This is mutually exclusive addition rule. Probability of A plus probability of B. But if it is not mutually exclusive, we need to subtract. That will be in the next. So mutually exclusive event, for example, what is the probability of drawing an ace or a king from the standard deck of cards? So now, as you know, ace mean A and king is the picture card with K. So how many kings are there in the total 52 pack of cards? 4, and 4 aces. So 4 over 52 probability of ace plus probability of king 4 over 52. So what will be the probability of ace or king? Will be 2 over 13. So with the different examples, I'll try to explain the mutually exclusive events. You can see the next now about the dice. The dice of an event are mutually exclusive. Event A, roll a 3 on a die. Event B, roll a 4 on the die. We have two dice, and it is not necessary if one is here, cannot be one here. Any number on first die does not affect the number on the other die. So that's why these are the mutually exclusive situation. The first event has one outcome 3. The second event has one outcome 4. These outcomes cannot occur at the same time. So that's why it is mutually exclusive. Again, it rains at AC. It does not rain at AC. Result of game, win, tie, lose. Outcome of rolling a dice 1, 2, 6. Not mutually exclusive definitely will be a randomly drawn card is 7. A randomly drawn card is a heart. It can be 7 and it can be heart of 7. It is not necessary if 7 cannot be heart. It is possible that 7 and heart come together at one card. Means it is possible the card is heart and with the number 7. So that's why it is called non-mutually exclusive events, which can occur at same time. These are non-mutually exclusive events. Now the probability of mutually exclusive events. These are the A. You are at school. You are bowling. So it is might possible you are in the school and bowling. And it is might possible you are in the school and not bowling. But it is might possible you are in the school and also bowling. So that's why A and B, this is the intersection area. This will be the intersection area. So that intersection area will be phi. Phi mean empty set. That's why it is called mutually exclusive. You cannot bowl at school. If you cannot bowl at school, then it will be mutually exclusive. But if you have bowling place in the school, so that will not be the mutually exclusive. So these are the different situations or examples you can see and read it. The same things with the different views I have collected for you, you can read it. This is for if you have two different probabilities and you can add these different probabilities by this situation. Non-mutually exclusive. Again, when two events A and B are non-mutually exclusive, the probability that either A or B will occur on a single trial. A or B can be at the same time. A and B can be at the same time. Then the probability of A or B will be probability of A plus probability of B minus probability of A and B. Means that we need to subtract the repeated situation. Now example. A card is drawn from the standard deck of cards. Find the probability of selecting either 2 or a heart. So if you find out the probability of 2, how many 2's are in 52? 4 over 52. And how many hearts are there? 13 over 52. But you know, there is a possibility that card can be 2 and heart as well. So if you count here 4, here 13, it means if the same heart as well as 2, so it will create error for you. So that's why that probability we need to subtract, and that can be one possibility, 2 and heart. It is not possible for the second time. It cannot be 2 times 2 and heart, because in one pack of cards only one card is 2 and as well as heart. So 1 over 52 subtract. Then you can easily subtract to get the answer of the probability for non-mutually exclusive. But if these are mutually exclusive, no need to subtract this because no common value. Now laws of probability. Event A and B are mutually exclusive if A can occur or B can occur but not both at the same time. A card drawn from the pack of could be an ace or the king. Ace or the king. Ace or the king, that cannot be at the same time because ace is a different card and king is a different card. It cannot replace with each other, or there is no intersection between these cards. So the probability of ace will be 4 over 52 and the probability of king will be 4 over 52. 1 over 13, 1 over 13. So now you can add these to find out the addition of probability. So these are the rules. The probability that event A and B will occur is probability of A plus probability of B minus probability of AB if overlapping. So you have to subtract. If there is no overlapping, no need to subtract. The same situation here, the same formula. For mutually exclusive, only probability of A plus probability of B, and for non-mutually exclusive, the probability of A plus probability of B minus probability of A and B. Hopefully you remember these two formulas. These are the important formulas for the addition rule of probability. Again, I am going to repeat for you. Probability of A or B is equals to probability of A plus probability of B when mutually exclusive event. Mutually exclusive mean that the event which cannot occur at same time. And non-mutually exclusive events, probability of A plus probability of B minus probability of A and B. It is for the non-mutually exclusive events. So now we are coming towards your book. See, this is the lesson, page number 276. You can see here page number 276. Addition of probabilities. If we select a card random from the pack of 52, the probability of drawing the jack is 4 over 52, and the probability of drawing red 4 is 2 over 52. There are 4 jacks and 2 red 4s. So if we want to find the probability of drawing either a jack or a red 4, the 6 cards which we would count as successful. The probability of drawing a jack or the red 4 is therefore 6 over 52, which is same as the sum of separate probabilities. We add the probabilities. If there are several separate events, we would count as successful. This is like the mutually exclusive, separate events, mutually exclusive events. But if the events are not mutually exclusive, we cannot say it separate. Notice though the probability of drawing the jack or the heart is, because the jack of heart is both groups. These things I have explained to you. You can easily understand it. This is like the tree. You can see here. Probability of red. That will be how many reds there? Probability of red. This is the question of, I think, in a box. If a box contains 3 red, 4 blue and 2 white, how many totals? 3 plus 4, 7 plus 2, 9. So probability of red will be 3 over 9, probability of blue will be 4 over 9, and probability of white will be 2 over 9. So these are the probability. Information can be shown in the diagram. Now we will try to show this into the diagram of probability. We have a box. For example, this is a box. The start of point is a box, and we need to divide this into the 3 categories: red, blue and white. Probability of red 3 over 9, blue 4 over 9, white 2 over 9. So if we want to either a red or the blue, either red or blue, so what will be the addition? Red or blue, 3 over 9 plus 4 over 9. If we want blue and white, 4 over 9 plus 2 over 9. If we want all, so the red or blue or white, so we will add all these 3. And you, as I told you yesterday, the probability of all the values, the sum of all the probabilities is equals to 1 always. Finding the number of outcomes. If we know that there is a 24 beads in a bag and that is probability of drawing a red bead is 3 over 8, then we know that the number of red beads is 3 over 8. 3 over 8 of 24. 3 over 8 of 24. So how many will be? 3 over 8 multiplied by 24. That will be 9 red beads. How many beads will be there? 9 red beads. Because this 3 over 8 representing that from out of every 8, 3 is red beads. So here how many times in 24? 8 how many times? 3 times. So 3 multiplied by 3 equal 9 beads are there. Now come to the question example. In a prize draw, the prizes are grocery hampers and garden center vouchers. The probability that the first ticket drawn in for the hamper is 1 over 200 and the probability that it is for the voucher into over 3 over 200. These are the probabilities. Just keep in your mind. These are the given probabilities. So what is the probability that the first ticket is for either hamper or voucher? Probability of hamper or voucher. What you will do? Just add the probabilities. 1 over 200 plus 3 over 200 because this is mutually exclusive event. So that's why that will be 1 over 50. Now neither a hamper nor a voucher. So as you know that the sum of all the probabilities is 1. So subtract from 1 this 1 over 50. So 49 over 50 will be neither a hamper nor the voucher. That will be the probability. Okay, now this exercise is for you. Next, inshallah, we will try to solve these 3 questions only today, and the next we will try to start from here, this next example. So your homework is only you have 3 questions from this exercise 16b. Take care. Assalamu alaikum wa rahmatullah.